Good morning and welcome to Graniterock's first virtual Tech Talk web series. My name is Keith Severson and I'm your host today. I'm the Director of Marketing and Community Involvement here at Graniterock. My job today is to help us navigate this meeting, make sure that we're in the right place at the right time, and asking some questions along the way. For your information, we will be recording this event for future reference. In a minute, I'll introduce you our first expert guest speaker. If you have questions during the presentation, please add them to the chat section and we will answer as many as possible. From there, we will roll into each speaker and questions in chat to follow. To make the most of everyone's time and stay on schedule, we may have to limit the number of questions that will be answered live. If there are lingering questions, we will attempt to get those answers to you along with the survey upon completion of today's session. For this program, we're asking everyone to keep themselves muted and your cameras off. The chat is open, so we encourage questions or comments throughout the meeting. Starting us off today, we are honored to have Fred Gius. Fred Gius is a supervising engineering geologist with the California Geological Survey and manager of the survey's Mineral Resources Program. His responsibilities include supervision of mineral land classification studies, geologic mapping of critical mineral commodities, and the evaluation of mineral hazard issues such as asbestos, radon, and mercury throughout the state of California. He's a licensed professional geologist and a certified engineering geologist in California. He holds a BS in geology from California State University, Sacramento. And Fred is a home brewer, a topic that I'd like to ask some more questions about when we get to the Q&A session. With that, I'd like to introduce our first guest speaker, Fred Gius.
Thank you. Good morning. Let me just get to my screen here real quick. I assume that you can see my presentation right now and hear me just fine.
That is correct. Thank you, Fred.
Okay, thank you. So I'm grateful for this opportunity to talk about something that's really important and exciting, and rocks. This picture that I have up here, this is the CEMEX Clayton Quarry. And I grew up, if you can see my cursor, right here. And I have fond memories, good memories of the quarry. I used to go up the hill, grab a piece of cardboard, slide down it, get run off by the landowners and the operators. The trucks used to drive by my elementary school. We'd get them to honk the horn. And then there's bad memories also. I remember my dad, goddamn trucks making all this noise and dust. And it wasn't until I was older to understand what Dad was talking about and some of the concerns that people have. So today I'm going to talk about, hang on 1 minute, my camera's not on, so sorry about that. I'm assuming it's on now. Okay, so today I'm going to talk about aggregate production. I'm going to talk about aggregate suitability, what defines construction aggregate. A little bit about aggregate sustainability, the supply and demand, and then some specific resources in the San Francisco Bay Area. Now, CGS, we've been studying and disseminating information on mineral resources for over 150 years. We are objective and scientific. We're independent of existing land ownership or land use, non-political. We're advocates for the resource as opposed to any mine or any local project. Bear with me, my advancing is not working. There we go. Thanks. Okay, so this is a report we put out in 2019. We do it annually. It's our non-fuel mineral production report. And this one here is based on 2017 data. California, it's an active mining state, and construction aggregate is the most valuable commodity. So you can see from this slide here that we led the nation in production of sand and gravel. We were second in the nation in Portland cement. And when you add up sand and gravel, Portland cement, and crushed stone, it's about 2/3 the value of the entire state. Very, very important. This is another display that we include in our annual report. It just shows the distribution of all the mines in California. These two attachments, one's for construction materials and the other is for industrial and chemical materials. We also present trends in that report. This one here is specific to sand and gravel, and you can see the trend since '91, since some of the data that we incorporated in the report. Another way we display some of the data. And this is an annual report of just the current status of production and value in the state. Let's talk about who uses construction aggregate. And when I talk about construction aggregate, I'm talking about PCC, AC, and base. Most of our products focus on PCC and AC. The Bay Area is a little different. There is a base component to it. So we can see from this slide, there's 57% commercial projects, 43% construction aggregate for public works. And it reaches a lot of people. So right here, this is just a quick slide of aggregate used in a home. 229 tons, they estimated. And so this is important. Aggregate should be important to everybody because it impacts everybody's life. And here's another use. This is of Tom's Gravel Company. You know, it's difficult to find humor on aggregate. This is the one I came across, and it does make me laugh. This is an important point. Not all rock is created equal. People think, why do you have to mine right here in my backyard? Why can't you just go over to the next hill? The fact is that I can't choose where these resources are. They are where they were deposited. They are where they exist. I don't have control of that. We do need to realize, though, that not all rock is equal. So depending on what might be in the deposit could have negative impacts on our use of the aggregate. For example, the chert that I'm showing there, the red one, there's alkali silica reaction issues. It forms a gel and it causes cracks and pop outs. The one right below that, there's pyrite. So it's iron sulfide. And so when that oxidizes, it oxidizes when it's exposed to air and moisture, and then that produces acids. It also results in a volume change that will damage the concrete. So we have to know what these materials are. The one in the upper right, that's the state rock, that's serpentinite. That's a nice quality aggregate. However, there's potential for it to have naturally occurring asbestos in it. So handling of it, processing of it becomes a problem. So you need to know these things. This is our map sheet 52. This is a really useful summary statewide of local supply and demand meeting the specifications for a concrete aggregate. The former state geologist called aggregate California's new gold because of the importance of it to the state. And so here we can see that statewide there are 7.6 billion tons in reserves. Demand is about 11 billion tons, so we're falling far short of that. We've identified 74 billion tons, so there's plenty of rock out there. It's just not accessible right now. Now I'm going to blow up a couple of the areas here just to look at them a little closer. So here's Southern California, the most populous portion of our state. There's 10 study areas in this slide. The circles, the relative size of the circles, the bigger it is, the more demand there is. You want to see circles with blue in them. So of these, you see a couple that maybe have more than 50% blue. That's 50% of demand. So Southern California, 2.2 billion tons reserves. The demand, though, is 5.3, so only 40% of it. When that starts happening, then they got to find rock from somewhere else, and they have to import it. Mexico is providing an interesting enough sand down in that area. So here's the Central Valley, Fresno, Bakersfield. Looks like it's in great shape. 2.3 billion tons of reserves. Their demand in that region is 770 million tons. So it's just in these areas right here, it's 30% of the state's reserves. Now, they don't need all that rock, so it's an issue of how do we get that rock to where it's needed? This is the result of some recent permitting that's been going on. There's a Solari sand and gravel. There's the Austin quarry that has a lot. There is the San Emidio quarry in Bakersfield. And so they haven't produced or been fully permitted to do all this. It's just, it's in the process. Now here's Greater Sacramento area. This is the most recent report we've done back in 2018. We combined 6 regions into one super region. And what's interesting and cautious about this slide is that here we are, we're showing that reserves and demand are okay, that there's enough reserves there. However, when you look at it, it's Sacramento area only has 15% of those resources, but it has most of the population and the demand. And then up there in the Yuba City, Marysville area has a lot more resources, not as much demand. So that rock from Yuba City still has to get down to Sacramento, and that's still a long way and will have some impacts. So just because a report might show that demand is being met, you have to really look at it as far as the distance and where these reserves are located. Here's our site. So this is the one we're talking about today, San Francisco Bay Area. And based on our data, 2018 data, reserves about 1 billion, demands over 2 billion. So we're falling well short of that. There's plenty of resources in the area. There's just not the available reserves right now to meet the needs, and that's going to be a problem. It's going to be a problem. Where do you get that rock? Importing it from farther distances.
Fred, I've got a question that I think is probably pertinent to the time now. What is the time frame used for supply-demand calculations?
That's a good question. It's 50 years. So we look at what the demand is going to be for 50 years. And so when you look at the San Francisco Bay Area, you have about half of the reserves. So you can think just roughly 25 years, we're going to be out of rock unless we find new reserves. And here's just an update. We do that report every 4 or 5 years. So we just finished the 4th one. Shows some general trends. The reserves went down and now they're back up, and it's in large part due to what's happening down in the Fresno Bakersfield area. The demand has stayed about the same. The areas with adequate reserves has changed a little bit, and the resources remain about the same. So this is updated about every 5 years. We get new information, new production data, new permits, new resources, and we add it to this report. I strongly encourage you to go find it. And it can also, one thing about that map that can be fun exercise for your kids that are at home learning is that there's 4 plesiosaurs hidden in that map. So my GIS staff who create the map, they thought it'd be funny if they put a couple of dinosaurs in there just hidden. And so you can open up that map and discuss it with your kids about the importance of aggregate, and also have them do a search for the dinosaurs in there. Now let's discuss the process we go through in determining the resources. And so under SMARA, the Surface Mining and Reclamation Act, the state geologist is responsible for classifying the state's mineral resources. And we do this through the process of mineral land classification. Again, our classification is neutral, third-party evaluation of resource significance. It's objective, it's independent of any land use, non-political. Again, we are pro-resource, not land use or mine. And we want to get this information to land use planners and decision makers so they can recognize the importance of these and that they're protected when we need them. We don't want a Walmart on our valuable resources. So responsible planning. Now, the steps that we go through. And this, I've given a talk on this subject by itself, about 30 minutes, 45 minutes, just on how we develop these resources. So I'm going to go through that quickly. That we establish a study boundary. The model used to be we wanted 95% of aggregate produced in an area was also consumed in that area. And that's what defined our boundary. So the boundary I have for the Bay Area, it was based on that model. That model doesn't work anymore. It doesn't work anymore in a lot of areas of California. There's too much import and exporting to use that model. We keep the boundary, though, the same just for comparison purposes. And then we identify areas that contain the resources, the mineral resource zones, and I'll go into more detail on that one. We estimate the amount of construction aggregate resources in the region, and then we provide an estimate on the reserves. And then, as important, we do our projections for that 50-year demand. Now here's our mineral resource zone. And this is these zones, they meet the criteria of the mining board, the state mining and geology board for classification, where 1 is there's no resource there at all. 2 is the most important one. 2, MRZ2s, we are determining that there's sufficient resources in that area, and these are the areas we need to protect. If a planner plans on doing something incompatible with mining on these lands, they must notify the state geologist and they must notify the board. And that rarely happens, unfortunately. So one of the messages from today is that it's, if you have MRZs in your jurisdiction, develop that mineral resource plan and get CGS involved on how you're planning to use that land. Here, this map shows the recency of our products. So if you can see my cursor, there's the dark green are the most recent ones. There's the Sacramento super region. There's about 31 study areas on this map. So here in San Francisco, we have the North Bay, which we did back in 2013. South San Francisco, we haven't done since 96. And then we have the Monterey Bay, which has been for a while as also. So we kind of use when was the last time these were updated as a determination on what our next project might be. It's mainly, though, areas that are at risk of having incompatible land uses. LA region is a huge area with that risk. We're currently updating several reports. We're working on the South San Francisco and the Monterey Bay. We're doing Saugus Newhall, San Fernando Valley, and Palmdale down in LA County, Simi Valley, and Ventura County. We are updating Merced County, Shasta County. Just got a petition from Tykert in Yolo County to classify some lands. So we are actively updating our reports. Okay, let's talk about now the actual resources in the San Francisco region. Let me look at my time here. I seem to be doing all right. This is the North Bay. This map you're looking at is the MRZ map. The purple on this map, those are the MRZ2. That is the significant resources in this area. And it's these resources that I then look at and determine if they have compatible land use. Those become sectors. So here's a sector. So this is an MRZ2 area that has compatible land use, and it meets a threshold value. In today's dollars, the deposit has to be worth $20 million to warrant a designation as a sector. And so these are the important maps that we include. These are the ones that land use planners need to use. These are the ones that operators can use to help identify where we have identified significant resources. The colors on here, the light green, that's the good stuff. That is a sector that meets the threshold, the money, marketable, and it has compatible land use. The dark green is incompatible land use. So it's either been developed, perhaps it's been mined out, and those are areas that have been lost. And then the orange on this is new sectors. So these are new sectors that we found since the last update, in this case 2013. And some of the highlights on this is the Russian River. It's between Hillsburg, just west of Windsor, and there's a lot of alluvial deposits in the river. A lot of them have been lost. About 185 million tons have been lost due to urbanization. We have the new sectors to the far right, which are sectors DD, and those are over by the Mark West quarry, AC grade basalt. The report goes into great detail of these resources and sectors and explanation. I'm just going to show, there's 38 sectors in the North Bay. I'm not going to go through every one of them, just some representative slides. So here's another area. And so the one on the left, it's all orange. So that's a new sector. That's the Gualala River, the alluvial deposits, PCC, and there's some plants up there right now. Just wasn't identified in the previous one, so we included it in this one. And the others are Sayers quarries in Napa, Lake Herman quarry, and then the San Rafael rock quarry. Now, South San Francisco. Look at the difference in those maps. This is from 1996. This is how we did it in the 80s and 90s. We didn't have high quality GIS that we have right now. A lot of this was hand drawn. This is difficult to read. I didn't put it up here so you'd understand what everything that's on this. This is what we're actively updating right now. This is also another project you can take home for the kids and have them color by number. You can see the 1, 2, 3, and 4s. So they're MRZ zones. Have them color all the 2s, and you'll see where all the significant resources are. We used to do them by quads back then, and we had different designators for compatible land use. Here's a blow up of an area. This is the Livermore Sunol area, and so the X's mean that they're depleted resources, been mined out. The hatched areas are lost to urbanization, so we don't want that happening. And the others are, it's owned or controlled by an operator, so we don't look at it that way anymore. So we're updating these maps to be current with our current standards and improve the usefulness of these documents. One thing that we did, and this is a draft, all we did is we digitized those black and white and colored them in ArcGIS. And so the green areas, those are our MRZ2s. Those are our resources. So we are currently evaluating those resources, making sure there's compatible land, and then identifying them as sectors. This is just a blow up of that previous map, just to show you. Some of the things we've displayed on this are the mine operators in the area, their different permitting status. We got dredge operations, and so this is what we will be evaluating right now to determine where the resources are that need to be protected. This is here's the sectors. Okay, so this is another update that we did. It's draft. It's just another way of looking at things. So we took all those green areas, and these are what show up as sectors from the 96 report. So this is a starting point for us, and then we're going to build off of it. Here's another way we're displaying some data. So spatially, all the purple, those are all the sectors. Those are the resources that meet the specs, that have meet threshold, $20 million, that are have compatible land uses. This is what we'll be updating. That report for San Francisco, we're hoping it's coming out. It should come out in 2022. Okay, here is Monterey Bay. Again, this map looks different. This is our current status. These are our current standards of the map. So here's our mineral resource zones. The important zones are green. This is what all of our maps will look like moving forward. Clearer to read. The detail is much higher quality. It's available in GIS so that it can be used in a responsible manner at the right scale. The one on the right is just a blow up of it, so you can see. Talk about sectors here, the important stuff. Same color scheme. Light green, it meets threshold and has compatible land use. Dark green, it's depleted, and orange is new. This is what the actual plates look like. So there's 2 plates for this report. There's 35 sectors. Let me show you, I'll blow up a couple of these areas so that we can see them. Okay, here is the Hollister area, the San Benito River, the sector, let me get my cursor, this area right here. So all the light green, that's available resources of the alluvial deposits, PCC. We have A.R. Wilson right up here. We have new sectors, and these sectors, Sergeant Ranch, I believe, and it's PCC estimated about 40 million tons. The one on the far right over here, new. This is the Hidden Canyon Quarry, and that's all I wanted to show you on this one. Here's a couple more sectors. So J right here, green. So it's J is actually, it's the former granite construction quarry. It's been reclaimed. Now, an interesting part about reclamation. Sometimes an operator will stop mining, reclaim the land, but we will still say it's a significant resource because maybe they only got to 100 feet of the deposit. Is it possible that technology improves in the future that allows us easier access to greater depths? Yes. And so we may, even though it's been reclaimed, still call it a available resource as long as it hasn't been reclaimed into something incompatible, like a preserve or a housing development. Here, down in the north of Monterey, lapis sand, really high quality sand. We are now showing that is lost, and we all may be well aware of what was going on there. There was an agreement with CEMEX to stop mining by 2021 and to sell it to a nonprofit. So that is going to be lost. And this is another new one. It is near it's Salinas Valley. This was a result of a petition in 2003. I haven't talked in much detail about petitions, but it's a process. Operators can petition the State Mining and Geology Board to have CGS classify land. So even if it doesn't show up on these maps and you guys want it classified for many reasons, we can do that through a petition process. I know my time is winding down, so the last bit of my presentation is the projection that we do. And so typically we have done a per capita projection where we look at historic production and then we look at population. So we're dividing production by population, and that gives us an average annual per capita consumption. Then we multiply the projection, the population projection by that per capita rate, and that gets us our demand. Example of that. That doesn't work in the Bay Area, like Monterey, for example. There's too much exporting going on. It really only works when there's production and consumption are in the same area. So here is historic production over 30, 45 years. So we'll plot that, and then we'll take the production divided by population, and we'll get this for each year. And we will do determine the average annual per capita consumption rate. And so it was 7.6 for this example. And then we will take that and compare it to population projections. And that's where you get the blue line for our demand. So that per capita times population projections get us the demand. If we don't have per capita, then what we do is we try to make some assumptions is past production rates similar to what it might be in the future. Here's the results of our reports for that area. And so you can see the resources we have identified are significant. There's lots of them. The reserves, though, very low amounts. And then our demand is significant. It's greater than the reserves we have for all three areas. And so that we need to consider, okay, how are we going to address that? Permitting additional resources, exports, imports, what impacts those are going to have. Tough decisions. So about the impacts, just real quickly, distance matters. Farther we're getting stuff, the greater the impact there is. The societal costs are like traffic congestion, the economic cost, road maintenance, environmental costs are greenhouse gas and particulate matter. So it is very important for these sources to be identified locally. San Diego did a really thorough study on this. They looked at transportation, rail, barge, ship, truck. Their conclusion was local truck by far is the best. Rail and truck, it could work. There are some impacts, but by far the greatest benefit is local resources. And that's all I got for you. And I often get asked, what is my favorite rock? Difficult to choose. And I'd have to say Chris.
Outstanding. Thank you. Thank you, Fred. We do have one question already on chat from Dennis McElroy. How has SB1 impacted permitted aggregate reserves in California?
It has impacted it in a way that stresses the importance and the increased demand that might come from that. And so we take that into consideration now when we look at our demand models. And there's many ways to determine demand. We just do it one way. We don't say it's the only way. We don't say it's the most accurate way. So SB1 we've used to support our demand.
I think I have. And folks, any other questions, put them in the chat for us, please. Very interesting. Since You had mentioned that you're a home brewer. Why don't you talk about your favorite home brew that you did, Fred, recently?
Sure, happy to. And again, any brew you make yourself and are sitting in your chair watching the Giants is the best beer. And I love IPAs. So we brew almost exclusively IPAs, and we are trying to mimic Russian River's Pliny. We're coming pretty close to it. So the double IPAs are always our favorites.
Oh, you're speaking to my heart. I love the Pliny. So Rich Satcher asked, expand on your truck transportation comment. We leverage our rail capability in our market pretty successfully, as you probably know.
Sure. The one of the greatest influencers on cost could be distance that the rock is traveling. And so by having local sources where the distance is not as great as it might be if it's coming from another region, say the Central Valley out to the Bay Area, those are going to add costs and impact a number of things, the societal, environmental cost as well. And so the Sandag report, I really recommend people cracking. It's a common sense approach to these issues. They're not telling you to do one over another. It's just findings, and it applies to all of California.
So what is the likelihood of permitting new resources in our area for mining, and how long does this process take, Fred, in your expert opinion?
You know, I hear the sad news that it can be a 10-year effort to permit a mine. California's tough. We know that. And when I go do national meetings, people wonder if we're even open for business. And so what is on our side is this carbon neutrality goal that California has. And local sources are needed to reduce the impact on carbon in the state. And so that it may help. It's certainly, permitting now is focusing on green energy commodities, lithium, cobalt, nickel, copper, those type of deposits. They just need to understand the importance of aggregate and that you can't have those other facilities, those green energy facilities. They're not constructed unless you're using aggregate and concrete. And so we're hoping that carbon neutrality goals, that they'll open their minds to also see the value of aggregate in that.
So we've got time for another question or two here, if you'd like to. Let's see if I can see this. What would you say is the biggest takeaway from your study? As an industry, what should we be focusing on?
You know, we stay out of politics, permitting, enforcement, compliance. And so I would say education, outreach is important. We must educate the land use decision makers on the importance of this, and that if we lose them, there's a greater impact to other regions. And so I focus on continued education so that people understand the significant importance of aggregate.
That was a really good question, Shane. Thanks. All right, if there are, I see no other questions in chat. Really educational, Fred, and I can't tell you how much I appreciate you being here for us and educating us on aggregate resources in the state of California. Next time we get together, we'll have to lift a pint and give it a try.
I'm going to go lift one in about an hour after we're done here. So
you have earned it, sir.
And one thing I didn't mention is that these reports, you can go to our website, you can request to get them. The Monterey Bay it should be done and out by, I'm hoping, the end of this month. So that one's coming out right now.
So give us that website real quick.
It is crap. It is Google California Geological Survey.
Okay, thank you. That's good. That's great. Very good. Thank you again, sir.
You're very
welcome.
welcome.
We're going to segue into our next expert guest, Dr. Adam Hand. Dr. Hand has a BS, MS, and PhD degrees in civil engineering and is a registered professional engineer in several states. He joined University of Nevada, Reno as a civil engineering professor in 2016. Prior to that, he worked for Granite Construction for 16 years, serving in various roles, and the last 6 years as the VP of Quality Management. He has published over 100 papers and technical reports. He actively serves the industry and the community via numerous technical committees, advisory panels, and board of director appointments, including several nonprofits. Dr. Hand, if you'd like to turn on your camera and unmute yourself, please proceed. Share your slides as needed.
Okay. Well, thank you for the introduction. I don't know where you found that one. It sounds better than reality. I'm really pleased to get to participate in your tech talk today. I'm really very passionate about recycling. You know, the presentation that we just got did a great job of summarizing you know, why we need to do all the recycling that we can, so we manage our resources so we don't consume them, and our future generations you know, can again exist where we've been existing, and you know, have the resources they need. I'm gonna go ahead and try to share my screen here. Share screen. Did that work successfully? Can you see my screen?
Can we? I can't see it. Yeah?
Yes.
Okay.
Okay.
Yes.
Great. I'm gonna bring up the PowerPoint, and I'm gonna use a few slides today, yeah, talk about building quality pavements with high RAP contents. You know, the industry as a whole has been really sort of focusing on this since every time there's a binder shortage, really the focus comes back up. But since the last round of that, a lot of really positive things have happened. So I'm going to try to today just talk a little bit about you know, recycling with or using RAP and asphalt pavements, and then some of the best practices that we can follow, and maybe share some of the sort of latest trends that exist, and you know, what other agencies are doing. So the types of recycling, there was a reclaimer on the cover of the presentation, or the warm-up, if you will, this morning. When it comes to recycling hot mix asphalt pavements, there's basically, we do cold in place recycling, whether it be a full depth reclamation or a cold in place that's at partial depth, where we stay in the hot mix, if you will. Cold central plant, where we might take millings back and then do some production in a small plant and take it back to the job. And then hot in place, which is not as common as cold in place or just plain old cold milling. And then there's hot central plant recycling, and that's what I'm going to focus on today, is just the hot central plant. When I think about recycling, I think about processes or techniques, which would be the hot in place, cold in place, etc., and then the materials. And there are lots of materials that go into asphalt pavement. Sometimes there was a state materials engineer in Utah for a while that he used to claim that asphalt pavements were horizontal landfills, and everybody wanted to throw their junk in there. But so there's a lot of materials that have been recycled in asphalt pavements, and this is really just going to focus on the use of RAP, or reclaimed asphalt pavements. And Reclaimed asphalt pavement is, it's obviously about 95% rock or aggregate, and about 5% asphalt binder. And in the slide here, you can see the pictures in the upper right. That's a handful of wrap, and then a close-up with a quarter. You can see some larger. That's some millings with some larger particles in there. And then in the bottom, there's that's a picture of RAS. And I'm not going to focus on RAS today, but reclaimed asphalt shingles are another source of material that can be used to recycle into asphalt pavements. The trick with using RAP, or RAS for that matter, is the fact that the material's been in place before. So as we know, when asphalt pavement is produced, the binder is aged through the production process, and then once it's placed, over time it ages, it gets stiffer. Well, that increase in stiffness can lead to some durability issues, and so when we're going to go mill a pavement up and reuse it, we need to be cognizant of the wrap that we're using, how stiff it is, when we make the selection of how much we're going to use, what virgin binders we're going to use with it, and if we may be using some other additives. And it's really important to note that environment has a significant influence on the stiffness of the wrap binder. And when I say that, the coast is actually a good place to do recycling. And the reason I say that, it's particularly possible in climates where the humidity is high and the temperature ranges aren't significant. Because when that's the case, the wrap material isn't aged nearly as much as can occur in other parts of or in other climates. So that said, what drives the use of recycling? Well, the cost of asphalt binder. When we see spikes in asphalt binder, we see greater interest in recycling. So we saw it in the 70s and 80s with the oil embargoes, and then in the late 2000s we saw a big uptick. If you look at this is a price index, right? Goes back to 2004. A lot of the cost associated with the index here, which is so high, is associated with asphalt binder. And so the real driver, even though asphalt binder is only 5% of a mix, and the aggregate's 95%, the cost of the asphalt binder is $500, $600, $700 a ton, as opposed to $15 or $20 a ton. And I'm ballparking numbers there, so don't quote me on those, but I'm just trying to give some sense of context. So what are the benefits of recycling in wrap into asphalt pavements? Well, got three categories here. Conservation, one of them is conserving the raw materials, right? So if we reuse asphalt pavement, we grind it up, we mill it up, and we take it back to the plant and use it for wrap, well, then we don't have to go mine virgin aggregates, and the asphalt binder, which has a significantly greater carbon footprint than the aggregates, we've got some asphalt binder in that wrap that can contribute to the mix. So we conserve those materials. Also, we don't use the energy, right? So the natural resources are conserved, and we don't use the energy that would be required to produce them. Okay. And then we also, in terms of the environment, the material isn't going into a landfill. It's hard to believe, but years ago it wasn't uncommon for wrap to go into landfills, or be maybe used as just shoulder backing or something. And then obviously with recycling, we reduce our emissions and our greenhouse gases. And so if we want to be carbon neutral by 2050, pick a year, right? So if the asphalt industry wants to be carbon neutral by 2050, we've got to reduce our greenhouse gas emissions. And again, recycling is a way we can contribute to that. And then economics are obviously important, regardless of whether it's taking wrap millings back to a hot plant and recycling, or in place recycling with cold in place or full depth or one of those techniques. We need to look at the economics of recycling, right? And the economics have to make sense, right? So that's always important. In different markets, the economics are different. And that's something that's particularly true when you look at sort of urban versus rural areas when it comes to the supply of RAP. And then also when it comes to economics, if we look at complete reconstruction versus other alternatives, for example, again, if you're in California, build a long life pavement and just go in and resurface, take an inch and a half or two off the top every 10 or 15 years and replace it versus complete reconstruction, and recycling is part of that process, then again, the economics can make sense. So it's just important that we don't overlook the benefits of recycling when we are considering economics. Now, the Federal Highway Administration has a recycling policy, and there are basically three elements to that policy. And you're used to seeing the triple bottom line when we talk about sustainability, right? So you see you see environment, economics, and society. Well, FHWA's Venn diagram has got economics and environment there, but it's got engineering there instead of society. And it's not that FHWA doesn't care about society, but their policy focuses on engineering. It says when you look at materials, right, you need to look at their suitability, their engineering suitability, and then their environmental suitability, and then you need to do an economic assessment to see if using those recycled materials makes sense. This is a memo, and there's a link to it up here that you can grab. What this memo in summary says, and there was a first draft of the policy was 2002, and then 2015 it was updated, and it states that recycling and reuse can offer engineering and economic and environmental benefits. Recycled materials should get first consideration in material selection. Determination of the use of recycled materials should include initial review of engineering and environmental suitability, and then obviously economic analysis. And the last item there is restrictions that prohibit the use of recycled materials without technical basis should be removed from specifications. Sometimes an agency will have an owner or an agency will have a bad experience with this recycle project and say, we're not doing this anymore. But technology changes, and the ability to do a good job of recycling, clearly exists today, and we're succeeding all over the country doing it today. So it's something that I guess I embrace that fifth part of the policy there, because it's something that we can do to do right for, again, the communities we live in and future generations. Now, this slide here is some ballpark numbers, and this goes back about, it's probably eight years old or so now, when we were producing as an industry over 500 million tons of hot mix a year. I know we're down around 4.25 maybe now. But at any rate, the idea here is to try to show some of the benefits of recycling using RAP basically in hot mix asphalt. And so what we've got, and these are percent savings. So with RAP, if we use 15% RAP, and this row is for 15% RAP, and this is for 25% RAP. And this stuff down here we won't bother with. This is shingles and warm mix, but we've got materials content, and then we've got price, energy, CO2 equivalent. So that's our greenhouse gas emissions. And then that's asphalt, cement, and aggregate. So if we use 15% RAP, we can save about 4% on our binder. We get about a 5% price savings. And pricing, again, is so market dependent. I just did some work for the National Asphalt Pavement Association, and we were looking at high RAP mixes, which were 35+%. And, we saw anywhere from savings of up to $8 a ton to costs in excess of virgin mix costs of about $2 a ton. So you have to be really careful again with the price piece, because it's market specific. But, we get a savings in terms of energy consumption, reduction in greenhouse gas emissions, and then conservation again of those natural materials. And as we increase the amount of RAP, obviously those savings go up. Then we'll go through the numbers, but the point here is if you think about sustainability and the triple bottom line and the FHWA policy, RAP is green. It fits all of those. Now, this is like I said, this was done when we were producing about 550 million tons of hot mix a year. So this is at asphalt binder tonnage, aggregate tonnage, the price of hot mix at that point in time, and then this is energy consumption and CO2 emissions in terms of tons. And you can see with 15, 25, and 50% RAP, just to demonstrate, you can see the estimated annual savings again in asphalt binder in terms of tonnage, in aggregate in terms of tonnage, and then in hot mix asphalt price in billions of dollars. Energy consumption in BTUs, and then reductions in CO2 emissions. So again, RAP is green. There's from a financial, natural resource, and sort of global warming perspective or climate change perspective, it makes sense. Now, this is the National Asphalt Pavement Association in partnership with the Federal Highway Administration does a survey every year, and I'm sure Graniterock probably provides input on that survey in terms of what the production is in California or Graniterock operations. And I just grabbed a couple slides out of the most recent report. The surveys are done in the year after a year is completed. So like this is the 19 survey data. The 20 survey is out right now, so it'll actually be published in late the fall of 21. But at any rate, what this slide shows is that almost 100 million tons of RAP is generated annually, and the bulk of that, over 90% of it, goes right back into hot mix asphalt, which is fantastic. Okay? And we can recycle RAP multiple times. There's no we can't recycle it anymore. This slide shows two different things. One is on the left, the tonnage, and on the right over here, the average percent RAP used. And this is a function of time. So if you go back to 2009, we all remember, unfortunately, what happened back then, the economy crash, right? And so there was obviously again a desire to increase the amount of RAP that was used in hot mix asphalt, and so we saw a climb, sort of a steady increase, pretty rapid increase actually, up until about 2014, 2015, and it's really been sort of flat since then. The dotted line is state departments of transportation. The red line would be other public agencies, and the green line is commercial and residential uses, and of course the purple line is the average. So we're at about 21%. So in other words, about 21% of mix has RAP in it. So that's really a good thing. And if you think about it, if you're recycling at a rate of say 20 to 25%, you have a sustainable, if you will, supply. Now the balance in supply will be different again in different markets, but overall it's sort of a sustainable balance of supply. Now this slide also from the survey shows what state DOTs allow. And 41 states allow greater than or equal to 15% RAP. 31 states allow greater than or equal to 20%. And 27 states allow 20 to 29%, or really 20 to 30%. There are 4 states that allow over 30%. Now, I touched on availability of supply and how important the market is. Also, the recycling volume and other uses. Sometimes there are competing uses. So, for example, some agencies say, we want our RAP. So when you generate millings on a job, you drop them off at our county yard and we use them. So it doesn't go back into hot mix asphalt. It can get used for shoulder backing, base course, and it could be used, cold in place recycle or full depth reclamation, So it could be lost to those uses also. So, and the reality is, in the example that I gave earlier about the work with Napa, if you're not a generator, or you don't get RAP at a fair price, if you will, relative to its value in terms of use in hot mix, then it may not be economical to use, and that's really unfortunate. We don't want that. We look at the performance of RAP mixes. This is a 2011 report done by Federal Highway Administration, and they basically looked at states and then what they call the long-term pavement performance, 20 years of data in the long-term pavements program from across the nation, from all the DOTs, and they basically came to the conclusion that RAP has successfully been used for more than 30 years. And if done properly, right, designed and properly, and appropriate quality control is imparted, then conventional and RAP mixes will perform similarly. So that was 2011. In 2013, there was a NCHRP project on same sort of thing. How do we improve our processes to do a better job of using high RAP? And additional data was available in a literature review on that project. They came up with a similar observation in terms of performance, and that's highlighted there in red. In-service performance of asphalt pavements containing up to 50% RAP in projects with diverse climates and traffic has been very positive. And this and I just clipped took a paragraph and got rid of some of the stuff in the middle. But again, the report in CHRP 752, you can go look at it. And basically that, overlays with up to 30% RAP have been performing equal to conventional mixes. The other thing that this report included was a recommendation to allow up to 25% RAP without making any changes in the virgin binder we're using. So we know that the binder in RAP is stiffer than the binder that's virgin binder going into a mix. And so trying to find the right balance of virgin binder stiffness to put together with that RAP binder stiffness so that we get good performance is the process can be a little bit messy in terms of chemical extractions and so forth. So during the 752 project, they recommended that up to 25% RAP be used without having to change binder grades. Now, I'm sort of trying to do a look back in time. So I said in 2008, right, 2009 we saw a big uptick. Well, in 2014, the FHWA issued a memo, and it was on high RAP mixes, and it wasn't high RAP, it was high RAM, which is RAP or RAS, high recycled asphalt materials. And it basically, gave some warnings about premature cracking or durability issues with high RAM mixes, especially with RAS mixes. And it brought to our attention the need to look beyond volumetrics in the mix design and how we could use performance tests to make sure that we were going to get good products. And the balanced mix design was a product of that. Okay. Now, in the balanced mix design, we'll talk about more in just a minute, but this slide has got a little video in it. And I said, why is this important, right? Again, as the binder ages, it loses its ability to relax stress. Now this video, this is a tensile strength test being performed. This is it's a 6-inch diameter specimen. And if you've ever broken concrete cylinders, the compression machines have cages around them because the specimens, they're pretty brittle when they break. The material goes flying all over the place. Well, we don't expect that with hot mix asphalt. That particular mix right there was a mix out of the I'll say the southern end of the valley, and it had a high RAP content, and it was a very brittle mix. It didn't get used, right? But the idea here is to demonstrate that's not what we're after. If we do that, if we use high RAP percentages and we don't use soft enough virgin binders with them, and the RAP comes from an environment like the valley where it's really, really stiff, we can get this sort of behavior. This is block cracking. in a relatively young pavement. And so that's exactly what we want to design to prevent when we do our wrap mix design. We have the tools to do this. The really good thing about being on the coast is that the wrap on the coast, and I'm 5 years away from working in California, so I don't know what numbers you're seeing today. So I might call on Shane or somebody to help me out here. But in the valley, you'd see PG 100 -4s. Now the PG is with asphalt binders, we grade them using what we call the performance grading system. And the first number is the high temperature grade, and the second number is the low temperature grade. So a PG 100 -4 is a much stiffer binder, okay, than a PG 76 -16. So in parts of California, we would see an increase in stiffness of the mix in place of about 4 times from what it was when it was originally constructed, where I think in the coast you might only see about 1 time. So that means that the wrap doesn't age as much. So you can recycle at higher rates without having to make significant changes in your virgin binder material. That's a really important point. So we have to look at our materials and understand them so that we can properly use them in the mix design. So I've got a sort of a list of best practices for high quality wrap mixes. And it starts with understanding our wrap. If we understand our wrap, then we have a better understanding of what we need to do in terms of virgin binder, whether we can just use the regular stuff or we need to do something different. We need to have good wrap management processes. That means that when we collect and process wrap, that we make sure we've got a good, consistent product to put back in the hot mix. We need to measure wrap material properties. Again, not only the source, but then when we take material back to a quarry or a location and we crush it, or screen it if we're not crushing it, just screen it. We may have a blend from different projects, from different places, different binder sources. So we need to look at those wrap material properties to make sure that, again, we've got a good product to put back into our new hot mix. We have to determine how much wrap we can use. We want to make sure that we want to use as much wrap as we can that's still going to give us good pavement performance. And that's the trick. I use a terminology all the time: responsibly recycling. Then we want to select, again, the correct virgin binder to mix with it. And then we want to do a good job on our mix design. So our sources of wrap, commonly it's millings, right? In the top upper right here, I lived in the Midwest for a while. I did a spell in Indiana, and that doesn't look anything like the Bay Area, I know, but that's a milling machine, right? So millings are the most common source of wrap, and then obviously other forms of pavement removal, and then plant reject from startups and any plant waste that might be available. When it comes to processing, so those are our sources. When it comes to processing, there's different things that can be done, right? One is you can take millings and just scalp them, right? You can build piles. What I've seen done very, very successfully is to collect wrap over time, whether it be plant waste removal from with a dozer or saw cutting, from patching, whatever, or millings, and build piles of wrap over time, and then actually mine those, build them horizontally, mine them vertically, run them through a crusher. And this is a little portable crusher down here. This is an operation where some wrap is being produced. Screen it and recirculate if you need to. And you can get a really, really nice, consistent product. The other thing is it's really important, so you know what you got. Okay. And I've got a slide here. This is pictures that I took at different operations over the years, and the question is it wrap or crap, And the point is there's far more value in high quality wrap than there is in poor quality wrap. You know, in the picture in the upper right here, there's hardly any wrap in here at all. This is actually a good picture. This is stuff that when, you know, trucks came in, it was debris that was collected out of the trucks. These are a little bit better piles of material that are being used to crush and make wrap from. And as I said, wrap not crap. That's not photoshopped. I took that picture on a wrap stockpile. There was a bunch of it was a house that had been remodeled, and there was a bunch of pink tile, probably from the 50s, along with some pink toilets in the wrap pile. And so, you know, oh, I just got a note. You have an issue with slide changing, Shane?
Yeah, we're still on the two milling pictures, on the Indiana milling pictures.
Huh. Okay, did that work? Did
No,
that?
We haven't seen it change out here at the end.
Page up? Anything going on there?
No, we're stuck on that one.
Huh. I stopped my share and restart. Let me try stopping my share.
Why don't you give that a try? Let us see what that gets.
Okay. Okay. Screen share. And I will grab desktop and reopen the PowerPoint. How about that? Is it back?
Yep, and that looks more like what you were talking about, I think. There's more.
Oh,
yeah.
Okay, sorry about that. I don't know what happened there. So those were the piles I was talking about, and that's the pile with the toilet in it. But now I want to show you some really good looking piles. So that's wrap, beautiful stockpile, beautiful material, very consistent. And I have actually seen, you know, in my when I worked at Granite, the wrap that was more consistent in terms of gradation than some virgin aggregate production. So you can get really good products. So that's a beautiful wrap stockpile. This is just some examples of wrap that are richer in asphalt binder than others, and that's a consideration. You need to know how much binder's in your wrap. And there's another beautiful wrap stockpile. So again, you can get really, you handle it properly. You can get great wrap that can then be used to make really good hot mix. Now, I said that we needed to measure our wrap material properties. We need to know how much asphalt binder's in it, and we need to know the stiffness of that binder, right? And then, of course, we need to know the gradation of the aggregate, so that when we're coming up with our proportions of virgin aggregates and wrap, that we've got our gradation that meets the gradation specification requirements. And then we need to measure like the specific gravity of the aggregates, and some agencies require that you measure things like fracture faces and other aggregate properties that probably aren't quite as important. Particularly when an aggregate's coming from the same neck of the woods, and that aggregate has been previously been used and it met the, you know, whatever the fracture face count and so forth prior to that. This is just some of the tools. Now, if we want to understand the binder properties, we have to we use a centrifuge extractor, and we get a solution of solvent and asphalt binder out of our wrap. We distill off the solvent, and we can then go ahead and measure the asphalt binder properties. And then again, this is the aggregate properties. Now, for QC, it's very common that an ignition oven will be used, knowing that the asphalt content indicated will be off a little bit, but you get a measure of consistency that way. Now, this is the data, if you will, for a binder, a wrap binder that was used for asphalt binder recovered from wrap. And there's a whole bunch of, you know, G-star over sine deltas and all this good stuff here. And we're not going to get into the details of this, other than to just recognize that with the PG binder grading system, we look at at the binder properties basically at high temperatures, intermediate temperatures, and low temperatures. And we come up with this high and low temperature grade. And in this example, the wrap had 4.7% asphalt binder in it by total weight of mix. And the PG grade was a PG 88 minus 16. That's a really, in terms of, if your location you're using, say a 70-10, if you've got a wrap that's an 88-16, that's great. You've got a wrap that's not super stiff, so you can use more wrap and still get, again, good performance. Now, there's a couple of different ways that wrap is specified. One is by percent wrap. The other is by what we call recycle binder ratio, or RBR. Now, percent wrap is, you'd say, okay, you can use 15%, 20%, 25%. Well, if you've got wrap, if you crush your wrap and you take and you scalp the coarse fraction off and maybe put that in a recycled base pile, the fine fraction has much higher asphalt content than the coarse fraction. And because of that, because you have more surface area, right? So the coarse fraction might have 3% asphalt or so in it, where the coarse fraction, or even less, the coarse fraction might have significantly more than what the asphalt, what the average mix, what the asphalt content of the original mix design was. And so if you specify on a percent wrap basis, you end up not really knowing how much of the virgin binder is being replaced by wrap binder in the mix. And that's why some folks use this recycle binder ratio. And all that is just the ratio of the weight of the recycle binder to the weight of the total binder in your mix. And so it's a fraction. So it'd be like 0.2 would be 20%. If your RBR is 0.2, then you'd have 20% of your virgin binders is replaced with recycled binder. Now, that was another recommendation of NCHRP 752. And so when you're trying to select the amount of wrap you're going to use, you need to know what specification you're working under, and then you need to know what the binder is needed in that local environment. So is it a 64-10, a 64-16, a 70-10? What is it? Okay. I've got recycling agents up here because many agencies are beginning to use those, and that, but I won't talk about them other than just to mention that. So again, NCHR 752, NCHRP 752, the recommendation was to use wrap binder ratio or recycle binder ratio, and that it be less than 0.25 if you don't want to change your binder grade. Now, over the years, something that's been done is to use something that's called blending charts. And that's where a minute ago I was talking about, you can extract your wrap and you find out what the properties of that binder are. And this is a sort of a dual scale plot here. I'm going to try to walk through this. On the bottom here, we've got the percentage of virgin binder in green and the percentage of wrap binder in blue. And so if we have 100% virgin binder, we have 0 wrap binder. If we have 20% wrap binder, we've got 80% virgin binder. Now, what this point here is just it's a measure of the consistency of the wrap binder. So it could be, it could be the penetration, the viscosity, it could be it could be a shear modulus, okay? So it's a stiffness. Now, and if this were the spec limit range for the stiffness of the binder in a given environment, in a given part of the state, well, our wrap would exceed that if the wrap came from the same location, right? Now, our virgin binders will either be somewhere in the range of the required or somewhere below it, right? Because we normally don't have on the low end, you can go below. So what this slide shows is if you want to use, say, 15 to 25% wrap, and your wrap stiffness is here, if you draw a straight line over to this axis, your virgin binder has to have a stiffness of this number, whatever it is. And then that allows for 15 to 25% wrap. Now this line can move up and down. Again, it depends. You could say, hey, I've got a virgin binder. It's right here, right? And so if I use it rather than getting something that's softer, I can still probably, use at least 20% wrap, maybe 22%. So this is just a tool that's been used to determine how much wrap can be used. Again, the NCHRP project, the most recent one, said just if it's under 25%, you don't need to change. Now this slide's really busy, and the point here is not to go through the details of this. This is a blending chart for looking at the binder low, intermediate, high temperature properties. And again, I don't want to go get crazy tech here. The idea is just to recognize that you can do that for both low, intermediate, and high temperatures, and that helps you select how much wrap you can use. Now, this slide shows the benefits of warm mix and how that can influence your binder selection. So this is a mix that has 25% wrap in it. Okay, this is the fall of 2008. And that's not my dog. I'm sorry, I can't mute that one out. The required binder in this particular location was this PG6422. So the virgin binder that was used was a PG58-28. So it was 1 grade softer than the target binder. Now, when we grade asphalt binders in the lab, we put them through an aging process that simulates a construction process. So this was the binder unaged. Now here's that same 58-28 after it's been put through the laboratory aging process to simulate construction. It's got this black line right here. Now this is binder recovered from mix, discharged from the plant. We extracted and recovered it and measured the binder properties. This binder graded as a PG64-28. It met the requirements for the target grade. That same plant, same day, we ran warm mix, and we ran at about 265 degrees, and we did the same thing. We extracted and recovered the binder, and it was significantly softer. And the point here is if you use warm mix, you can use higher wrap doses and not have to change binder grades. Okay. So that's enough on the voodoo of G-star, sine delta, and all that good stuff associated with binder specifications. And I want to move on now to mix designs. The most recent NCHRP project, and I apologize, I'm using NCHRP project and NCHRP report, not saying what those are. NCHRP is a National Cooperative Highway Research Program. So this is research that's done by funds that are pooled by all the state highway agencies in the country. So all the DOTs are members of, all the AASHTO members pool their money, and they pick 3 or 4 projects a year to do significant national research. And the most recent project on wrap mix design was NCHRP 933, and they basically came up with the mix design process, which is consistent with what I was in the slides that I shared. Is basically go get your materials, understand the properties of them. If you're using more than 15% wrap, look at your binder properties. If you're using less, just proceed with your volumetric mix design. But also do some mix tests. And this is something that's pretty powerful today. We've got some really simple tests that can be used to look at the performance of recycled asphalt mixtures. Since you're in California, you're probably very familiar with the Hamburg wheel tracking test on the left. And on the right is a couple of different cracking tests. This is it's an ideal CT. It's no different. It's identical to the indirect tensile strength that you use when you run your moisture sensitivity tests on a Caltrans project, for example. And the idea here is we want to make sure that we've got both good rutting resistance as well as cracking or durability resistance. In this slide, this is a slide that Francis Veen developed in the late 20s. And it's really, again, it's a balanced mix design, having the right balance of enough asphalt binder so that we have good durability, therefore cracking resistance, but not so much that we have rutting. And that's exactly what we're trying to do with this balanced mix design approach. It's being promoted today. It's being promoted by the Federal Highway Administration, as well as the National Asphalt Pavement Association. A couple of things for the RAP designers that are on the meeting today. It's really important as you know, when we're using 15% RAP, it doesn't matter. But when you start using 25% RAP or more, if you're not measuring the specific gravity of your RAP aggregate, you begin to overestimate your VMA, your voids and mineral aggregate. If you do that, you'll think that you're meeting the specification requirements, but you're not, and it means you're shorting yourself a little bit on asphalt binder, and you want to make sure you get enough binder in your mixes so we have good durability. And of course, we have to be mindful of the fact that RAP has fines in it, plus it's milled, so we need to be managing our fines in the mix design process so that we've got mixes that are producible in the field. Some other best practices for high RAP mixes is obviously, you know, making sure you've got RAP available. The consistency I talked about in terms of processing. Then you get to RAP moisture content, and again, depending on where you are, the picture in the bottom left was taken in Reno, Nevada, and in summertime we don't have any moisture. You got 2% moisture in your in your blend of materials, but with RAP, it's like sand, for example. It'll hold a lot of moisture, so you want to make sure you're managing your moisture. You may want to pave under your stockpiles or even cover them, depending on where you are. If you've got a lot of moisture in your environment, you got to make sure you have the right plant processing and production equipment to use RAP. This particular plant, they're running up to about 30% RAP. They're using 2 feed bins. It's a counterflow drum. With parallel flows, you can't run as much as you can with counterflows, and then if you put an external mixer on a counterflow drum or use a drum in a drum like one of the Aztec double barrel plants, you can run even higher percentages. But the idea is make sure you got the right hardware in place so that you get a good product coming out of your plant. And then again, your virgin material properties have to, you have to make sure you're starting with good virgin materials. And I think that, part of this whole process is looking at your sustainability goals. What are you trying to achieve? And it may be, hey, there's a shortage of aggregates in our environment. It may be that millings are hard to come by, or we've got a glut of millings. And what are our virgin material supply in terms of asphalt binder and aggregate in the market? And you have to sort of optimize those goals, and then make sure you have the right designs and plant resources to produce good mixes with them. And so, I've got the question posed here: how do we responsibly maximize the use of RAP? And it's that in itself is a best practice. Some barriers, that it's funny. I've been doing talks on using recycled RAP and hot mix asphalt for 20 years, 20 plus years, actually about 25 years now, and there's always barriers that have to be overcome. And so if you think about it from a contractor and an agency perspective, there's change, right? People don't like change, right? So we have to overcome the fact that it's a change management exercise. People don't like change. Contractor wants to make sure that it makes economic sense to them, right? They're going to have to make some capital investments to have the right hardware at the plant, right? To get the right raw materials. They've got to have space, right? If you're in an urban area, you don't have a lot of real estate. You've only got so much space to store materials, right? There are technical and engineering. The bar gets risen a little bit when you go to high RAP mixes, so you need to make sure you got your technical game on cue. You have to go out and market it, and again, it goes back to your sustainability goals. Now, at the agency, I think it's not much different. Again, there's change, right? acceptance is really the agency's responsibility, whether that again is a public agency or maybe a private owner, but it's the owner's responsibility to determine how they're going to accept that material. It may require some specification changes. There may be some cost or price savings in contractors, and please don't get mad at me, contractors in the room, but I watched this over the years. If you're the first to recycle in a given market, you have a cost advantage for a short period of time, but contractors are margins are so low, contractors are so committed to getting work that they end up giving that margin away over time. So any savings that comes with recycling, as there's competition in the market where everybody's recycling, that savings evaporates. The owner gets it. There may be some changes in asphalt binders that are used, again, which we do for the agency. But again, you got to go back to your sustainability goals. And so there's a long list of barriers, and I've crossed out barriers and said they're opportunities, because sustainability, it really is important. It really is important today. The National Asphalt Pavement Association has a whole bunch of resources that again, they're wide open. The Federal Highway Administration contribute to funds to the development of most of them or many of them. So they're unbiased or reviewed by FHWA, most of them. Recently, they published this Sustainable Asphalt Pavements Practical Guide. It's a 4-part series. It's got a lot of good stuff in there. There's 4 sections. Section 2 of it has got 92 things that you can do in your operations to be more sustainable. NAPA has got a laser focus on sustainability right now. The annual meeting was just last week, and sustainability was a big piece of the meeting. And that is because the new administration in Washington is laser focused on sustainability. When President Biden, if you look at his infrastructure plan, you've got sustainability and resiliency in there. And I think under the current administration, we're going to see funding tied to reporting around sustainability. The ASC infrastructure report card just came out, and boy, we got another poor grade on our roads. So there's a need for investment in our roadway infrastructure. And again, like I said, it's becoming more and more important for lots of good reasons. This last slide here is just again, here's a bunch of NAPA resources available to you. Some of those you can go download for free. Some of them you have to pay for. But the stuff around sustainability is all free. And this is their most recent publication. That's on balanced mix design. And again, it's all about how to increase the use of recycled materials and do it so that you get good performing mixes. And with that, I will wrap up. And
absolutely fabulous. Thank you, Dr. Hand. That was great. We do have one question already in the queue. Our Bay Area market is a mill and fill market where every ton of HMA supplied produces a ton of grinding wrap. At 20% wrap, we have a 4-to-1 wrap grindings versus HMA production ratio. Have you completed any studies that help address the supply versus demand issue?
Well, so that's a really good question. So on a project working with FHWA, we visited 6 or 7 states 2 years ago on RAS, the same issue with RAS, and then last year with RAP. The issue, right, in the urban areas is exactly what you're talking about. So the solution is to use more. I mean, the reality is now, as you go to higher wrap percentages, you may have to deal with your virgin binder, but you can do that. You may have to drop a grade, for example. So in my opinion, the solution is to go ahead and use it. With the higher percentages, and just get your binder right when you do that, and you can get very good performance. I think that there's been a fear. It's like I had a materials engineer one time tell me that he asked me the question. He asked if I would buy a car, or when I bought a new car, I expected that I was going to have recycled tires on it. Trying to make an analogy to using wrap in hot mix asphalt. Well, again, as long as we can evaluate the materials and know we're going to get good performance, it doesn't make sense, in my opinion, not to recycle. So my response is use it. I don't know if that's helpful or not.
Very good. Thank you. And so some other questions out there in the field? Who else got another question? And while we're waiting for some additional questions, Fred Gius was kind enough to put into our chat the link to the geological survey. So you guys can look in your chat box about that. Thank you for that, Fred, by the way. Any other questions? Adam, just outstanding. Really a wealth of information here for us. Thank you so much.
You're welcome. Thank you for the opportunity to participate today. And if you do get more questions afterwards, don't hesitate to send them my way. I'd be happy to respond to them.
Will do. Thank you again.
Sure thing. Thank you.
Now it's my pleasure to introduce one of our internal experts here at Graniterock. Stuart Mager is the Road Materials Business Manager and is responsible for Graniterock's HMA, Recycle, and Emulsion division. Stuart has worked in the industry for over 25 years in various capacities, including research and technical services, sales, managing quarry, HMA, and concrete operations. He's a graduate of Auburn University and earned a master's degree in civil engineering while working at the National Center for Asphalt Technology. Stuart has previously served on various asphalt industry technical committees and is currently a registered professional engineer in California and is the proud father of 3 kids. Mr. Mager.
All right, good morning. Can everyone hear me and see my presentation?
Yes and yes.
Okay, thank you. So I was going to continue to talk a little bit about what Adam spoke about. And the purpose of my discussion today is really to talk about the challenge we have with grindings and the use of wrap in the Bay Area. So let me go back to the top here. So historically, for years, we've sold millions of tons of wrap mixes in the Bay Area, and mostly without failure or quality issues. Now, I can speak for Graniterock on that, but I know the other suppliers in the Bay Area are all selling wrap mixes. And if you just look at the volume from San Francisco, and I'm just speaking to the folks in this room, but if you look at San Francisco to San Jose, easily over 1 million tons a year sold in that market, and perhaps a little less when you go south of San Jose to the Monterey County market. And so what that creates is a need for, when you're an HMA producer, you have to provide contractors a place to dump. So many jobs now, especially in the Bay Area, are grind and pave. And in that market, it's so urban, it's very different than the southern market, where in the north, there's no place for contractors to take grindings. There's no farmers that want them. You're not going to go dump them in some field that just happens to be somewhere. Contractors expect that HMA producers are going to provide a place for them to take those grindings and then pick up asphalt in the same trucks or maybe a different day and go out to the job. So that creates an issue with a lot of inbound material. And the other thing that happens in the Bay Area is a lot of the construction is either vertical construction or remove and replace, where if you look at some of the rural areas, San Benito County, southern Santa Clara County, there are opportunities for growth, even in the San Jose market, where you've got tech campuses going on, housing developments, warehouses being built. There is a larger demand for base rock in those markets than there is in an urban area. So what it creates is an imbalance. A lot of material coming in, but not as much going out in wrap. And that's my talk today, is to help you understand that we as HMA suppliers have a challenge to be able to handle all that inbound material when the specifications for asphalt are limited on how much we can put back in the HMA. So when we talk about RAP and grindings, it's the combination of two non-renewable resources, right? There's binder in there and there's aggregate. And we use that to replace the virgin binder in the rock. And so the goal should be for us to reduce the down cycle use in base materials, because you're taking a virgin, a binder and rock, mix it up, make a hot mix, and then some point years later you grind it up and you bring it back to the plant, and you can either put it in RAP or that material goes in a pile and it's ground up and it's put in base rock. So you're not utilizing the binder part of those grindings, which is the most expensive. So here's just a map of our locations in the Bay Area. And so really what I'm talking about is San Francisco down to Seaside. And if you look, it might be hard to see on this map, but it has a recycle symbol. And those are places where contractors can actually come in and dump grindings or broken AC, broken concrete. And those are for us. So all HMA producers have a spot in their yard to do it. But the remaining recycle people that are just in the business of recycling grindings or concrete or base rock that comes off a job is limited, and those sites are filling up, and in the urban area, in the Bay Area, there's less and less of them. And I believe in the years to come, we'll see even less. So there's an urgency to figure out how do we utilize these grindings that are coming off the job and stop trying to make base rock out of them. So here's a picture of our site in Redwood City. And what you can see, I just want to kind of give you some scale. If you look in the back, there's that big rubble pile. And that pile of rubble there, just for some scale to you, is probably around 200,000 tons. And if you look on the right, the dark patch in the back, that's the grindings that come in. And then in the front, there's finished RAP, and then there's what we make of base rock. So the picture really is to tell a story that of all the rubble that comes in, because a lot of it's mixed, coming from jobs, and we'll talk about that in a little bit, not everything can go into RAP. So you have to separate products into clean grindings. Then you've got material that comes in on site that was grindings, but maybe the agency required a 3-inch or 4-inch mill, and there was 2 inches of asphalt. So the contractor's bringing back 2 inches of asphalt, 2 inches of base rock. Well, when you make RAP, you can't have any aggregate in there. It's not what you need is clean grindings, asphalt and binder mixed together. So what you can see here is we've got this huge stockpile of rubble in the Bay Area, and we're trying to make base rock out of it because a lot of times we don't have the space to either. We can't move the grindings out fast enough, so it becomes a geographic issue where we can't take all the clean grindings and make RAP. Or the contractor has the mill too deep, so he's got base rock in there, so it goes into a rubble pile. So really what we're trying to do is take that rubble pile and minimize it and take the grindings pile and increase it so that more of that material can go under RAP. This is a graph. I did my best to kind of take what I thought was information from the Bay Area and made a best guess of just give you a reference what's coming in. So if you look at this bar chart, and the bar on the left is probably all your dumps that would come into a facility in a given period of time. And then the next one over is just the HMA dumps, and that's broken AC and grindings. So the difference between the first bar and the second bar is really would be concrete rubble coming in. Then your next one is your grinding dumps. There's clean grindings. And then the next bar is how much RAP you can put back in just based on your limitations in the spec. So you can see there's a vast difference between just the amount of HMA material coming into a rubble site and the amount of RAP that goes out. It's almost 4 times as much coming in as what you're able to send out. So rubble, it requires a large footprint for storage and processing, and there's just not a lot of land available to do this. And as we get encroachment, we got environmental concerns we have to be accountable for. We have housing developments, So no one wants to see this next to their site. So it's tougher and tougher to operate in these environments. There's less sites willing and able to take all this material. We talked about the mill depth. Sometimes that causes a mix of grindings and base rock to come into a site that's not usable for wrap. So when you look at what are we selling in the Bay Area, I talked about probably well over 1 million to 1.5 million tons a year of asphalt just in the peninsula to San Jose. And if you just talk to all the producers, yes, we're making wrap mixes with 15 to 20%, but if you took an average, it's probably somewhere around 10% on average wrap going out from any producer per year. So, and the cost to manage this rubble is increasing. And so what happens is to manage it, you've got to charge contractors increasing fees because you get to a point where you can see our yard, there's no room to take anymore, right? So what is a contractor to do when he's got to grind and pave? So what we're looking for is how can we make more wrap to help reduce the amount of rubble that's just sitting in the yard. So, for years, it's been this misconception that wrap is a lesser quality product. And I think people are starting to see that it's not so that anymore, right? There was a time, and there still is a time, that same agencies just don't want to use wrap. They feel like I had a bad experience 5 or 10 years ago. But like I said, there's millions and millions of tons sold in this area and very minimal quality problems because of the wrap. It usually turns out to be something else, constructability or a design issue, but rarely is it someone could pinpoint, well, you've got wrap in the mix and that's why it failed. So most specs locally have about a 15% wrap limitation or none at all, right? And for those agencies that are putting on there, I understand it. We'd love to work with you to see if we could help change your mind, but we know there's a reason for why you're doing it, and everybody here is smart, and they're making the best decision for the people that they're serving in their county or city. The other thing kind of limits things is most HMA plants are designed for 25% wrap. So that run from where we are at 15% to get to 25%, right, is not a big movement for most companies. But to get above 25% is significant capital investment. And I would say HMA producers would be reluctant to make that investment unless they knew that the payback was coming in a short period of time and that the specs would be changing and evolving, right? Sort of the chicken and the egg. Because as you increase wrap, you've got to increase your binder storage because as you get above 25%, 15 per Caltrans, but you've got to lower your binder grade, as Adam talked about, to account for the higher stiffness of the binder and the wrap. You got to start to manage your wrap, the fractionization, manufacture it into different sizes, which requires more land space, more bin storage, that kind of thing. The more wrap you put in a mix, the more fines you create. The more fines you have, the more difficult and challenge you have with air voids and BMA. And then as well, the more wrap you put in the mix, the asphalt plant needs to change significantly. You have to upgrade that. Bigger burners, bigger drum, different way you process the wrap. And then your lab capabilities have to change. There's more resources required, more testing. So there's a lot of big investment. But companies, I believe, would be willing to do that because the return on investment with higher wrap is a savings again in aggregate and a savings in oil. And for an agency, that means that costs can, over time, come down for you and be more competitive. And they're also, you sort of have not a hedge, but a pillow against the cost of crude. As crude increases and you're using less virgin binder and more wrap, then there's a slight less fluctuation when oil goes up because there's some cushion that contractors have. So at the end of the day, just for Graniterock, we have a lot of extensive experience in putting together HMA designs with wrap. We're starting to see agencies use SuperPave. A lot of agencies are starting to add higher wrap contents or put wrap in their specs. So I think we're here. I'm here. We have a lot of good folks in industry that work for Graniterock. That I think the key to this would be to have a partnership where agencies and the HMA suppliers could work together to figure out what works in that certain climate, that works for your traffic levels, what kind of jobs you're doing, and build specifications that are responsible, provide a good quality product, but at the same time help us utilize more RAP. If we're going to continually to grind and pave, we've got to figure out a way to utilize more RAP. Otherwise, it's going to get to a point where it's going to be very, very expensive to try to figure out how to manage this. Because if you look at what you do with RAP, if you turn it into base rock, it's really, and there's so much in the market, it's not really a lucrative business. So, I would just say the way to be responsible about this is we got to figure out a way to put more RAP into asphalt. That was the gist of my presentation, just to talk about the challenges we have and to open the door for any questions that we can answer as Graniterock, and what we're doing and how we can help you as a local agency. If you care to utilize more RAP or figure out how we can start putting it in your specs.
Outstanding. Thank you, Stuart. What questions do you guys have out there for Stuart, or any questions about the day at all? Put them in the chat. We'll be happy to review those at this point. Shane, do you have another brilliant question?
That's a good question, Jessica.
Hey.
I'll get to it here.
Sorry.
From your stockpile photo, what is the difference between clean grindings and RAP?
Let me go back here. So clean grindings is what's coming off from the millings from any grinding operation. Clean grindings would be strictly grindings, no underneath base material. RAP is what we do after if you look over here, if you can see where my cursor is, that material's taken over here and put through a crusher. It's either
you've got to share again, Stuart.
Oh, I'm sorry. Sorry about that.
We're just seeing your handsome face here.
All right. It's not enough for everybody. All right.
There you go.
Okay, get that up. So this part here is the grindings coming off a job, and this pile is after it's been crushed. So grindings have to be reduced down from a larger size. Those things come in 1 inch, 2 inch, 3 inch or better. And we put it through a crushing process here and basically crush down to 1/2 inch minus right now. When you get to high RAP, you may have 2 or 3 different size products depending on what you're making.
All right, now we're rolling. All right, Stuart, can you give us an example of an agency that is doing a good job with specifications for increasing RAP use?
Well, I think if I were to look, I think mostly everybody in the Bay Area is allowing somewhere in that 15% range. I know we do supply a lot of material in the city and county of San Francisco, and they are currently looking to build increase their lab capability and they're going to be looking to increase the amount of RAP in their mixes. Is the meetings we've had with them. They're big believers in recycle. They grind, take out everything it's a grind and pave market. And they understand that they just want to use more recycle. So that would be one. But I think a lot of agencies right now are at least doing a good job of allowing 15%.
Thank you. So if an agency wants to increase RAP percentages in their specifications, who should they talk to?
So I know I represent Graniterock, and we're looking at this as an industry, I believe. So I don't want to sit here but you can talk to us. There's good people like Adam. Adam's a sharp guy. could probably way more knowledgeable on the technical side of how to increase wrap in your mix than myself. But if you wanted to talk to somebody at Graniterock, there's plenty of us, myself, Shane, Kevin McNeil. We have another person, Brent Grankador, is really knowledgeable. So we get you a list of Graniterock folks and industry folks to talk to.
So Ed asked a good question about how do you address the infiltration of paving fabrics?
So for us, it depends how big it is. If it's small pieces, we have a process we use to remove the fabric. Sometimes you just get rolls of the stuff and you can't get it all out. And then what happens is you can't make wrap out of it. It ends up in your base rock pile, or a non-spec base rock pile. But if it's significant, we do our best. But when it gets really significant, you can't put that material back to an asphalt plant.
Is Caltrans flexible on increasing their max 15% wrap?
Yeah, they are allowing 25%. And Adam, you could correct me if I'm wrong. Above 15%, they're requiring a drop down in binder grade. So you have to change the binder grade on the material. And there's two schools of thought on that. I don't want to put words in Adam's mouth, but there's a lot of experts out there who believe you're okay running up to 25% without a change in binder grade. But Caltrans, and I know, and Adam could speak to this, but I believe there's they have a goal of working towards 40% as well. There's a study that I understand is going to take place or is taking place now to hopefully get that percentage up.
And Stuart, can you see Zach's comment here? In addition, public agencies follow the Caltrans spec 2018 and can't exceed what is recommended.
No, and I understand that. That's a tough one. I think what I would advocate is there's agencies within the state of California that are doing more than Caltrans does. So a lot of times there's opportunities to, if an agency would look at, we could help them get up there. I understand the limitations, but if there's agencies that aren't beholden to that spec, I think we could do a good job of helping them move up. And I'm not advocating that you have to be 40% today, or I advocate that let's work past that 15% barrier and move towards 20-25%.
Or 15% opportunity, as Adam called it, rather than a barrier. Yes, okay, any final questions real quick? Outstanding. Thank you all very much. Thanks everyone who took the time to join us today and for the insightful questions and obviously for our speakers. Just can't tell you how much we appreciate the effort. That concludes today's Tech Talk. Join us again on next Thursday, March 11th, where the discussion will include aggregate sustainability in California and in-place pavement recycling strategies. If you know somebody that may benefit from the next couple of Tech Talks, please forward the invite as you wish. Be safe, everyone, and rock on.
Thank you.